Erez, feel free to take it over.
Okay, I am looking for. I don't see the. I wanted to get kind of the laser pointer
Oh, I know
mouse.
what you mean.
I don't see the sharing toolbar that usually come, but it's not that critical.
Host tools. Hmm. Uh,
All right, I can get started while you look for this. It's
okay.
not that critical. Okay, welcome everyone. My name is Erez Zadok. I'm a professor at Stony Brook University. I've been there for 25 years working on data storage and file systems. With me is my senior PhD student, Tyler Estro, who's been instrumental in this particular project. And we'll tell you about how we've developed courselets on Chameleon to help train and teach storage systems. So to start with, we'll overall just cover this talk will cover about four topics. What are the challenges in storage education? How do we go about designing the course and infrastructure? How do we develop and publish the actual courselets and some lessons that we've learned? So storage is kind of hard to teach. The experiments themselves are kind of difficult to deploy at a classroom scale. Storage systems are stateful, they're slow. There's one sort of well-known tautology in storage systems that you're not allowed to lose any data ever or corrupt it. That's not acceptable. And yet you need to experiment with destructive operations. What happened if my storage is dead, if my system is corrupt? How do I recover? How does it look like? And all that stuff requires that you have isolated environments per student so that they can do the experiments safely. Now, you want to also experiment with multiple devices of different types so they get the feel for the speed, the size, the performance characteristics, and you want to be able to reset the environments. And having that is also fairly hard to set up. Physical machines are just too slow to set up, to reset, and limited in use, typically. And for anyone who's doing any kind of storage research or teaching, you're going to need multiple virtual machines to do some of the storage experiments because some of them have to do with network storage, distributed storage, where you need multiple nodes. So these kind of general challenges. Um, the course that we had last spring was special topics for graduate students on storage systems. I've taught this course a couple of times over the years, but I've also taught topics from this course in other systems courses like programming and operating systems and system administration over the years. So these kind of modules have been very useful to have. In the particular course that we had last year, we had 20 graduate students, and we wanted to have a variety of hardware and file systems and various storage technologies like RAID and virtualization. So the way we did the course, at least part of the course, there were two phases. In the first phase, we already had some courselets that were developed in my lab by Tyler and other students who've come to the project. And we said, we're going to just have the students in the CSE 590 class run those courselets so they get the feel for how they look like, and then survey them, what did they like, what they didn't like, so we learn from it. And in the second phase, sort of the next homework assignment, they would actually design and develop and test one of their own um, storage courselet and then demo it. Tyler also gave um, a couple of guest lectures to the students on how to use the courselets, how to develop them, the Chameleon environment, the notebooks, how to initialize. So that was also very helpful as a training. So the process that we've gone over some 25 years, going from left to right, in the beginning, we used physical machines because that's what we had. That's how you were doing any kind of systems, either research or teaching. And of course, you were very limited in how many devices you had. There was no isolation. The experiments were not safe. Every small mistake meant reinstalling the systems from scratch, and that was way too time consuming. Then we moved in the kind of the early 2000s, I would say, to using virtualization, using VMware. At the time, VMware was offering um, free educational licenses for teaching and research purposes for academics and teachers and students. Not all the products were available, some of them, and usually the licenses were annual and had to be renewed. So that allowed us to move to virtual machines, which was very convenient. We could create different virtual machines, but it was still we still need to do instructor managed all the virtual machines. The licenses were proprietary, of course, and we had to constantly renew them. And it still didn't scale very well. Not that the VMware ecosphere didn't have that support. It's just that the licenses that were available to us didn't provide the full gamut of their cloud and scalability offerings. And then, unfortunately, about a year and a half ago, when Broadcom acquired VMware, they stopped the educational license program, and so we all had to find some alternatives. And eventually, many of us have moved to the open source Proxmox system. It's more versatile, it's got more flexibility, but it still has kind of similar issues that the instructors have to manage the process or the TAs, and it doesn't scale as well. Not that you couldn't set up a highly scalable system, but it's just so much work. And then it's not something that we can afford to do in academia. Plus, it requires quite a lot of hardware infrastructure that we don't have. Um, so eventually we when we started to work on this project, we realized that's really the right architecture, and so we moved to the Chameleon infrastructure, um, where actually we started with some physical machines because Chameleon supports it, and then we realized that it will be more flexible for us to use virtual machines. And so we moved to virtual machines. The system will self-provision. The students can provision the virtual machines, run the experiments, learn from them, and then when they're done, everything resets from scratch. There's also APIs that are flexible that we have actually contributed to some of those APIs along the way. We found some limitations, um, and um, and so now there's a lot more. There's a richer infrastructure for designing additional kind of courselets. And some of the best feature is that this is cloud scale. This is a massive operation of multiple clusters distributed throughout the nation with others that can join in and contribute their equipment when it's not in use. So really, the scale is not nothing that we could potentially support inside a university. Okay. Um, so what are the kind of things that we done when we're teaching storage systems on Chameleon? We did a number of different topics. One is a safe failure scenarios, like how does RAID systems operate when they begin to degrade when some of the devices are not operating, and then that way we're not putting any production data at risk, and we actually see what happens when what does data loss looks like, and can you recover from it, or how do you mitigate or prevent it in the first place. Um, we could do repeated runs because you can reset the experiments if something you don't like or you want to restart it. It's literally just a click away and you start it from the beginning. If you make any mistake, not a big deal. You learn from it and then you kind of repeat as a learning process. Um, Also, with with the virtualization infrastructure, we found it to be sufficiently quick, so that there's not really much delays. You don't have to deal with actual physical hardware, which can be slow at times. You can even run some performance benchmarks, which is something often you do in storage systems. The topology is fairly flexible because we can set up as many disks as we wanted. All the other infrastructure like IP addresses and networking in the operating system, all this stuff is taken care for us. We can set up environments that are suitable per experiment. And lastly, one of the more important things for us was that when we started to work with um, notebooks, we realized that the most popular type of notebooks are written in Python. But Python is not the language of choice for system administrators who are managing or developing storage. It's going to be root shell, and you run commands in shell or in bash. So we had to set up a different kernel for these experiments so that the users or future administrators could actually see what it looks like as realistic as possible. And finally, we published all these artifacts on Trovi after vetting them and testing them, and we now use them internally when we onboard new students to my lab. I just tell them, hey, go run all these courselets, and try them multiple times so that they learn from it. And the nice thing is that they can be reused again and again from semester to semester. Um, so the baseline that we started as an instructor is we had 5 courselets that were already ready. One was just how to initialize a virtual machine because that was kind of an important module for all the other ones. And then we had 4 more on some basic topics like disk partitioning, how to benchmark and get some performance measurements, and 2 of RAID flavors that are slightly more complicated. We use this to onboard the students and to provide them with a template that they can clone and copy and make their own courselets. We then, after the students have run through the 5 existing courses that we had, we broke them up into teams. Some people wanted to work alone, some worked in larger teams. We gave them kind of a long list of courses to choose from, and then we assigned we try to make as much as possible one-to-one assignments so that every course that we thought could be developed would have at least one team working on it. The teams worked for 3 weeks using the instructor model. Then we went through multiple rounds of reviewing. This was more of a iterative process as opposed to your traditional classroom project where you give in a description, you submit at the end, you get a grade. We really wanted to help them develop it. So they met with the TAs and me periodically to kind of show them what they have, to ask questions. That they interacted with other students. How do I do this? How do I do that? And then we iterated multiple times. At the end, they had a demo of each one of their courselets, and based on that, they received the grade. There were a total of 16 submissions, and we selected 12 of the best ones and curated them a little bit after the course, cleaned it up a little, make sure that all the style is conforming, and then we published those on Trovi. The Our experience in the first parts of this project taught us how to structure these courselets for storage systems to be in kind of a nice standard structure for each of these courselets. So we start with learning objectives right up front so that people would know what you're going to get at the end of it. Then we set up the hardware requirements for the particular experiments, what kind of CPU, how much memory, how many disks, how big they should be. And then you go through step-by-step cells that alternate with explanation and an executable code. So every cell starts with a description of what you're about to see, what is a command that's going to be issued. Then you run the command, and everything is well documented. And after you run the command, we run another command to verify that what you just did actually worked. It could be just visual verification, or it could be running some other commands that indeed test to make sure that what you did. This is very common in kind of advanced storage administrators where they're running relatively dangerous commands that could be destroying data and creating formatting disks, partitioning them. So we want to make sure that when you run a command, you verify that it actually worked, and you don't move forward until you've verified it. And then at the very end, we go through a set of cells that just frees up all the resources, cleans everything up, and we go back to initial state. So that's how we had order courselets set up. Now here's a list of the published courselets that we had. At the top, you see the 5 that we already published from before: the VM initialization, basic disk partitioning, how to benchmark storage system, and 2 of the simpler RAID flavors, striping and mirroring. The students authored and published 12 courselets. 4 of them were on file system features. 2 were on symbolic links and hard links, which are a bit of a kind of more advanced features that sometimes confuse people. Like, what's the difference between symbolic versus hard link? And 2 were on a more advanced file systems available in Linux, one called BTRFS, the other one is called XFS. These are copy on write file systems with snapshotting capability, so they have some more advanced features, and the course that specifically show you those, highlight those specific features. We had 2 courselets on space efficiency, one on how to use compression, one how to use compression with deduplication. These are both space-saving mechanisms in storage systems. The next 2 courselets were on block management. LVM stands for logical volume management. That's the ability to shrink and resize volumes on demand. And one was on caching. How do you cache from a slow device to a fast device to speed performance? And then, of course, you can run the benchmarking courselet on top of it to test that actually your performance is improving. The next were on data security. One was using the device mapper, a virtualization layer in Linux to run the integrity, or basically the checksumming of every block. And the other one was on encrypting. How do you encrypt blocks is, again, common ways to secure against data theft by encrypting all your data. And the last ones were on network storage. That required multiple virtual machines to test the network file system version 3 and the latest version, version 4, that are available on Linux. And those are the courselets that the students had tried. So there's overall a wide range of courses that touch on many aspects of the storage stack. Some are simpler, some are kind of intermediate, and some are more advanced. And there's enough experience now that people can develop, clone these and develop some more on their own. Okay, so that is my part. And if there are any questions, I'm happy to answer them. If not, Tyler can take over now and go through some demo and show you some of the survey results that we had.
Great. Thank you, Erez. Are there any questions from our participants? Feel free to use your raise hand. You can raise your hand. I'll unmute you. You'll be welcome to ask your question live. You can also drop a question in the chat. Erez, I do have one question for you myself, which is,
Yeah.
I'm curious, when you were developing the course, like the materials and kind of laying out your curriculum for the semester, were there any concepts in that you would have liked to cover that you felt like just didn't really fit well with, you know, the rest of the course, or specifically, some of the more interactive things? Or were there particular things that you would have liked to have included but couldn't because of limitations, like on Chameleon specifically?
Um, I don't think there were any limitations on Chameleon per se. Well, once we got everything working, that was if you remember earlier on, the APIs didn't allow us to instantiate as many a variable number of virtual machines.
Hmm.
Sorry, a variable number of virtual disks per virtual machine. It was fixed to 1 or 2 or something like that. So that was some of our small contribution to the API. And now we can
Yeah.
instantiate as many virtual machines as we want, which is exactly what you want, because in RAID 5 you need a minimum of 3, and in RAID 6 you need a minimum of 6.
Hmm.
So we were really just limited by not having more students in the class. If I had more students in the class, I would have loved to see a RAID 5 and a RAID 6. And the other things that I would have liked to see is a distributed system, like setting up, 3 or 4 nodes with something like Ceph or Lustre.
Mhm. Yeah,
It's just a matter of having more time and students to put these together. But I think that
for
some
sure.
of our current courselets are an excellent starting point for somebody to just take, clone, and adapt.
Yeah, yeah. No, that's great. I asked because I'm interested in, if there were things that you would have liked to have done, but were not even limited by Chameleon, but just limited by the current state of the field or, by what the standard processes are for teaching these kinds of topics. Um, so yeah,
Yeah.
anything beyond Chameleon that you can think of?
I don't know how easy it is to write code interactively, like C++ code, that talks to storage systems. Because the reality
Mhm.
is that any kind of storage system or appliance is still, the code is vastly in C and C++.
Mhm.
Not in scripting languages. Scripting languages are used more for benchmarking, for testing, for administering, but any kind of distributed system, or network system is going to be in C and C++. So we wanted to find out if there was a way that somebody can just type code that looks like it's C or C++ in a cell, and it will compile and run it and show you the results. Um, but I don't know if
Mhm.
that technology exists. It's more of a Jupyter issue.
Yeah. Okay, great. Well, I have another question, but maybe I'll save that one for the end.
All right.
Yeah, I can pick up if you want me to let me
Okay,
share my
so I can
screen.
I can stop share.
Yeah, 1 second. Okay, you guys can see okay.
Yeah.
Looks great. Yep.
Okay, so I'm not gonna do like an actual interactive demo because that'd be a little too much, but I do want to just walk you guys through the collection of courselets that we have, and then one which I think is a pretty good example. So we published this collection here. This is on Trovi. I'll put the link for this in the chat at some point. Um, so you could see the 17 courselets we developed, as well as the 5 instructor ones are here as well. These are all the authors who worked on it, and I'm going to show you the ButterFS courselet here. This one. So mostly, I just want to show you guys the format. All of the courselets should generally follow sort of the same guidelines, so they look pretty similar. So you'll see sort of we asked students to give some background up front. So they describe what ButterFS is. They give you some of the key features. It's a B tree based file system. It supports snapshots, built-in RAID support, um, and then most importantly, one of the main things that we asked students to do was to define all of the learning objectives up front. So, um, for each course, this is going to be different. So you'll see right here, they say, understand the structure and advantages of ButterFS. They tell you some of the tasks that you're going to perform throughout the courselet. And we also asked them to define the hardware requirements up front. So for this course, it's pretty simple. You just need 2 disks. Others were a little bit more advanced. You'll see we had 2 NFS courselets, so those required to create 2 VMs, and there was a lot of more advanced networking setup than this particular courselet. So following that, they followed sort of that same strategy that Professor Zadok talked about, where you describe the command that you're about to do. and then you show it, and then you verify afterwards what the command did. It wasn't always necessary for really simple commands, but you can see they generally follow this. They give you a description of the set command. We also asked them to provide links for any documentation for any commands that they used. So you'll see this here. There were other times when we asked them to provide, for more advanced topics, like if you want more info on this topic, go to this link. So that was also really useful. So they follow that format throughout. So here you get to a little bit more of an advanced command where they're actually partitioning the disk. So they have the command here, but then we also asked them to sort of describe the output of each cell as well. So you can't see the output here because it's just a preview, but they give a nice description of what you should expect when you run the cell. So yeah, they basically follow that format. You can see as they get more complex, there's more links. They try to describe the syntax very well. We wanted to make sure that people who were beginners to sort of doing the stuff on command line understood all of the syntax that they were seeing. One thing that this person didn't do, we also asked them to provide explanations for any arguments that they provide. So if you provide the F argument, the L argument, ideally you would have some explanation of what each one of those does. Technically, it's in the documentation, so maybe we let it slide, but yeah. So then they continue on with this format. So after the initial setup, they go into sort of more of the features. So this course was really nice. They did a really good presentation of all of the more prominent features that you would be interested in for this file system. So they have some nice background up front. They give you a link to sort of more info if you're interested. Yeah, see here they describe the arguments. But you can see it's pretty much the same format over and over again. You have the description, what you're about to do, the code, and then you explain the result. And preferably you're verifying the result of every command that you run afterwards. So they go on, they explain subvolumes and snapshots. So they do a really nice job of explaining all the features and having a nice comparison. You see at the end here, they go over copy on write, deduplication, right, and so on. So the other thing that we asked them to do at the end was to make sure that they cleaned everything up, right? So they wanted to free all their resources because Chameleon's a shared resource. So for this particular setup, they did some local cleanup for their own VM, but then also at the end here, you'll see sort of this reminder in red to make sure you free all your resources and what that all entails. And the details of doing that is in the VM initialization notebook that we provided here. So I won't really go over this in thorough detail. I think probably if you use Chameleon, you're familiar with this sort of thing. So, but it follows the same sort of format, right? Actually, maybe this is slightly interesting to look at. So this is part of what we contributed to the API, the sort of the ability to add and modify volumes directly through the API itself. Previously, you had to go on the Chameleon GUI and do this yourself. So this was very, very useful for the course. So that's pretty much it. I don't want to labor too much on these. They all look pretty similar, but yeah, they came out really nice. And I'll post the collection for this in the chat.
Yeah. One interesting point there is that because it's all virtualized, we can create small devices that are perhaps unrealistic in today's environments, but they're perfect for the teaching purpose. If you wanted to do it on physical hardware, it will be difficult to find a hard disk that's less than multiple terabytes. And so that's just a lot of unnecessary size and capacity and work. With the virtualization, we can set up virtual disks that are a gig in size or something really small, and that's perfect for the to teach the principles, but it speeds things up considerably compared to physical hardware.
Right, absolutely. Yeah, very flexible with Chameleon, which was great. Um, all right, so after, well, to rewind a little bit, so before we had them develop their own courselets, we gave them those 4 onboarding courselets that we made on our own. And then we had asked them to fill out a survey on what they thought afterwards. So the survey went as follows. We asked them 3 questions per courselet, whether they learned something new from the courselet, whether it improved their understanding, and whether they thought it was like an efficient way to spend their time. So we had 20 students. They responded on a scale from 1 to 5. So as you can see, everything came in above 4, which was great. Wasn't really a lot of variation. So disk partitioning scored the highest overall. Benchmarking had a slight outlier at 4.05 on efficiency. But otherwise, based on this feedback, we thought it was a really good outcome for the first run of this course on a platform that like most of the students mostly had never used or had any exposure to. So in addition to these ratings, I think what was maybe even more useful is that we asked the students to provide detailed comments on any courselet. So I'll go over some of those as well. So these are some of the comments that represent sort of positive recurring feedback that we've received. So the first was on courselet format. So students liked being able to sort of go at their own pace while still running real commands. And this wasn't really, too surprising. You're using Jupyter Jupyter notebooks, and Jupyter's popular interface just for this reason, right? As far as the courselets themselves, they said mostly that the RAID courselet stood out for them. They received a lot of positive comments, despite sort of like not scoring as high in the ratings as the others, if you recall the previous slide. And I think this probably had to do with the fact that the material was both sort of the most novel, but also more complex than the other courselets that we had given them. So another student had said that the sort of the introduction to doing storage work over the command line interface was new for them. So this particular student had mentioned that they only had used the GUI for disk management. So I think that this format, the courselet approach, was really like a gentle introduction to using the command line that is suitable for first-time users, I guess, in this case. So we also received a lot of constructive criticism. The first was on interpreting output. So students would say, they ran the benchmarks, they got a bunch of numbers, but they didn't really fully understand what they were looking at. So the fix for this is just to ensure that we have some kind of explanation of any of the output to any of the code cells, which you can see in it, sort of in how we ask the students to develop their courselets. So the next was some students didn't really have a lot of prior storage background. So they found that the material was just like a bit difficult for them to get into. So again, here we just asked that they include adequate background up front. Just don't assume that they understand all the material. Assume that they're a beginner. And furthermore, we asked the students to provide those useful links or to documentation or other websites in cases where there was a lot more material that they could learn. So lastly, the students mentioned that the guest lectures were really crucial, and they felt like they would have a lot of trouble getting into it otherwise. And it seemed like it was particularly the case for the VM initialization notebook. So here, sort of, we wanted to just make sure that as we were designing the courselets, we were just very thorough, and we explained every single step, in extreme detail for every courselet. So we also got some negative feedback. Some students felt like the courselets were more of a walkthrough than an actual assignment. And I think this is a common critique for like a Jupyter sort of interface, right? You can kind of just run all. And so I think it's important to consider ways where you can get the students to be more interactive with the courselet rather than just running all the cells. So this might involve opening a separate terminal, asking them explicitly to modify code within the cells rather than just running it. So we also had one other student who thought that some of our content was AI generated. I didn't personally introduce any of myself. Some of the students I was working with may have, but just wanted to include this because, people may not have much tolerance for sort of, the AI generated slop, or as they say, right? So lastly, some of the students just felt like this maybe was not the best format for teaching the material. And valid criticism, not a whole lot we can do with it, except for, understanding that there's always room for improvement, I guess, right?
I'm just curious, if the student have a specific um, idea of how they would have learned better? What format would have been better for them?
I don't recall their other comments. I did this was literally all he wrote regarding that. So I think he actually may have included another comment that was somewhat similar. He just didn't seem to like it, I guess. Thus, he made it to the red slide instead of the orange one, basically.
Yeah, yep.
So the important sort of thing to understand about all of this is the right sort of friction can actually be extremely useful for teaching storage or just systems in general, right? So the complexity of setting up the VM, figuring out how to provision storage volumes, we sort of want them to struggle a bit with these tasks in the right way, of course. So we want to sort of force them how to get it right while also presenting them with, these controlled failures and, guiding them on how to handle these failures when things go wrong. And the thing about Chameleon is it gives you this really safe, flexible environment to do that. You can break it and reconfigure your VM all you want, and you're completely isolated from other students. So you can just reset and get a clean slate as you need. And this, as Professor mentioned earlier, this wasn't always the case in a traditional lab setting. So to conclude, we designed a storage course, which was designed to entirely be run on Chameleon. Chameleon, as I said, gave us this really flexible environment suitable for storage coursework, and it allowed students to learn safely through friction. From an instructor perspective, it's just vastly more simple to manage and scale, for a classroom setting, more so than traditional approaches. I took the course myself many years ago, and I can definitely say that this was the superior approach in that sense. So we introduced the concept of students learning through developing their own courselets, and this resulted in us publishing 17 courselets on Trovi. And we believe this model is pretty straightforward and easy to apply. So the result is that with the right infrastructure and the right course model, you turn every semester into sort of these lasting contributions, and these can be reused for teaching or onboarding students into a lab or something like that. So that is the end of the presentation, and we could take Q&A now.
Cool. Well, thank you both so much for the presentation. I think that was really interesting to hear more about how you approach this, how you were working with the courselets, what the students struggled with, and how they benefited from it. So thank you for sharing all these insights. I'll just repeat, if you want to ask a question, you can use the raise hand function or put your type your question in the Q&A box. The other question I had for you was about actually, funny enough, like the use of AI, which kind of came up at the end there, but I think I'm thinking of it more in a different context of serving as an additional learning tool. And I'm curious if you have thought about that at all, as an instructor, and how that influences the idea of, maybe it makes it even more important to create digital content like this, that students can view as trustworthy and authoritative. But yeah, I'm just wondering if that has come up at all, and whether you've thought about how to implement it or how to keep it out of what you're doing.
I haven't personally thought about it too much. I think in general, I think encouraging the usage of AI is good, and specifically the usage of the correct usage of AI, not sort of. I think when people complain about AI or AI slop, they're really just talking about someone who lazily asked the question, dumped the results immediately. Not so much that they use it as a tool to sort of enhance their own work, right? Um, so I think that would be the best way to go about it, to be upfront if you are using it, and then sort of, you know, promote responsible usage of it within that
Mhm.
context.
So I would hope that that AI can, or at least the LLMs can find courselets like these and mine them or harvest them so that when somebody asks questions, it could use that as the AI answer. I don't know if the Trovi courselets themselves are kind of available, the full content, or you have to actually instantiate it to see it. That might be something interesting, if that can be done, because I would much rather that um, the AIs will give answers based on trusted courselets that have been developed and vetted than giving you some random answer from the internet, which in the context of storage system can be disastrous. If you're using the wrong command and you don't understand something, you will lose all your data. This is like the big no-no in storage systems. Thou shall not lose data, period.
Yeah, right. That makes perfect sense. Yeah. Um, yeah, I mean, I'm wondering if there's some kind of future lab where you're having a student interact with the AI system while working on an assignment, and uh, building something like a courselet in a more collaborative fashion. But I don't know. I'm kind of spitballing things here and thinking out loud. So
I
yeah,
think
no.
we're all in academia now, trying to figure out how to integrate AI into our uh, academic research and teaching. And there's still a wide range of um, feelings and responses from the total prohibition to total allowance and everywhere in between. But it seems that more and more we're going to be moving towards a world where you're allowed to use it, and you have to maybe declare that you've used it, and then you have to think about how you teach things in such a way that AI won't be able to give you the answer very simply.
Hmm.
So, for example, in this particular course that I taught uh, last spring, um, there were additional assignments where they had to uh, pick some storage software code written in C in the Linux kernel and add some features and fix some bugs in it. Um, and I knew this was challenging enough that AI would not be able to just give you the answer. If it did, I would have done it myself. So I told
Yeah.
him, go ahead, use whatever you want, any resource in the world. I don't care. Any LLM, any AI, if it helps you to find the bugs and to add the features faster, great. But when you demo it, you have to explain every line of code that you added if I
Hmm.
ask you about it. And that seems to be kind of a trend that a number of instructors are going in general. Um, yeah, I
Yeah.
don't know if that's what's going to happen, but that's at least what I hear.
Yeah, that's very interesting. Um, all right. Well, we're coming up on time here, so I'll just close it out by thanking you both for your time and also to say the the link to the artifacts that were discussed today are in the chat, and we'll also post them on the web page where we upload the video from today, as well as the slides that were presented, um, so that folks can take a look at the courselets as well, and see if there's anything of interest to them. And yeah, I think we'll have the video up later today. So we'll have that out, and folks can go and check it out as well. So thank you both, Tyler, Erez, for coming today, and thank you to the audience. And we'll see you at our next webinar series.
All right.
Thank you.
Thank you.
Thanks so much.
Bye.